Have you ever wanted to make your own six-pointed snowflake? We've made a worksheet that you can use to make your own six-pointed snowflake, and I wanted to show you how it's done. We've also produced a printed sheet which has all of the lines marked on it already so that you can fold it nice and easily, or if you prefer, there's a blank version which you can use to make a nice blank snowflake, and I'll show you how to fold the paper. The first fold is folding the whole page in half, and you'll notice that if you do this, the circle lines up perfectly so that you end up with a fold straight through the middle of the circle. The next fold is just a crease to fold the whole thing in half across, and then you open that one out. You will then also need a crease at the quarter line, which is here, and you fold it like that. And then open that one out as well, and you should be able to see a line at the halfway point and a line at the quarter point. Next, you need to take the corner of the piece of paper, bring it across onto the quarter line so that the top edge of the fold goes through the halfway line. And you'll notice that if you do this correctly, the circle will match up exactly. This will give you a 60-degree angle here at the top. Now, if you fold over this other section, the whole thing will be folded exactly into 6 parts. You can then use this sixth of a circle to make yourself a snowflake. If you cut along this line, you then have a piece which you can cut pieces out of, and when you unfold it, the snowflake will have hexagonal symmetry. We've produced a sheet of puzzles to challenge you, because you could just cut any old random bits out of this, but what's quite difficult is to try and imagine what shape you will get when you unfold it. So in this worksheet you can see there are 6 different challenges to produce these exact shapes, and you have to work out exactly what you need to cut out from the shape you've got here in order to produce the whole thing. As an example, I'm going to show you one which isn't on the sheet. So first of all, I'm going to cut out my circle so that I've got a circular piece. Now if I unfold this, you'll see it's a full circle. And if I fold it back up again, I can now cut out some kind of shape from here. So I, for example, will cut this triangle shape. And now if I unfold this, I should get something with hexagonal 6-fold symmetry. In this case, I'm getting a 6-pointed star, which is quite Christmassy, but I think you can produce something even better. So on our sheet, the 6th challenge is to come up with your own design of snowflake, and you should draw it out first and then try and imagine what it's going to look like when you unfold the whole thing. There's also an additional challenge if you fancy trying to prove something with mathematics. So we've produced an extra sheet headed Snowflake Geometry, in which we challenge you to try and prove that the angle produced using this method is exactly 60 degrees. You can do it using a little bit of measuring, a little bit of trigonometry, but have a go yourself and see what you can get to. If you've had a go at trying to prove that the angle is 60 degrees, I thought I would share with you my method of proving this. So I'm going to start off with my circular piece of paper folded in half, and on this side I've marked the 2 fold lines so it's very easy to see where they are. In the folding method, you take the corner of the page and fold it across to here, so that the corner of the paper lands exactly on this line and the top edge of the fold is exactly where the halfway line was. Now, if we look at what we've got here, it's a right angle triangle, and in fact this triangle can be quite easily seen, if I mark it with a pen, to have sides of lengths that we already know. So for example, if we call this length here 1, then if I open this out again, you might be able to see that this length, the length of the hypotenuse of the triangle, is actually 2, because this was a quarter and this is a half of the length of the whole page. So in fact we can mark this length as 2. This means we have a length 1 here and a length 2 here. And if we know anything about trigonometry, we'll know that the cosine of this angle is the adjacent divided by the hypotenuse, which is 1 divided by 2. So the cosine of theta equals a half, which means theta equals 60 degrees. So this angle here is 60 degrees. If you manage to prove it using a different method, that's also great, because there's quite often more than one way to show something in mathematics. Well done!